definition of chemistry? Recall your memory. The study of matter. Matter is everything. So we study its composition, we study its properties, we study its transformation. Suppose we have a piece of coal, so we see that what are its properties, we see what is its structure, we see that how it what happens when it transforms into coal, into ash, etc., etc. So this all about chemistry, tells you the properties, etc., etc. Then we chose the book, in our book, chlorine is chosen as a sample. The chlorine has more than 1000 elements, 1000 compounds, which are extensively used in our daily life. You can see on the screen, like for making PVC pipes, for example, for making chloroform, for making DDT, I told you in detail, pesticides, water drugs, you can see, I told you that they are refrigerant gases, the gases which are used to cool down, cooling agent in our refrigerators, in our ACs or other cooling machines, etc. So all of these are the different compounds of chlorine. So only chlorine we discussed, and we came to know that chemistry is really very, very important. It plays a very vital role in our daily life, right? So chemistry and its effects are everywhere, like different kinds of food, might be it's butter or margarine or tomato ketchup or this sauce or that sauce, all are, there's shampoo, soap, fertilizer, cosmetics, cement, glass, this and that, all are the products, blessings of chemistry, right? Similarly, chemistry is related with science and technology, cooking, cleaning, medicine, this and that, all we have discussed. Now, what is the main topic today? Branches of chemistry. Internationally, there are 5 major branches of chemistry: organic, inorganic, physical, analytical, and biochemistry. But in our book, they have discussed 9 different branches of chemistry: organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, biochemistry, 5. Then industrial chemistry, polymeric chemistry, environmental chemistry, and nuclear chemistry. So we'll define and see these branches one after the other. Let's start the first one. So we start with the first one. There's a question for you. What do you mean by the word compound? When 2 or more than atoms combine together, they form a compound, like an element hydrogen, another element oxygen. Hydrogen and oxygen atoms, when combined, they form a molecule of water. Carbon and oxygen, these are 2 different elements. They combine to form what? Carbon dioxide or carbon monoxide. So carbon dioxide, carbon monoxide, water, all of these are nothing but the compounds. Okay, so that's why the definition is there. You can see on the board, on the screen, 2 or more than 2 atoms combine chemically to form a compound. Now the question is, we have about 118 elements, which you can see in the periodic table. How many estimated compounds are there of all of these elements? According to Wikipedia, let me tell you one thing. Whenever you see a cross at the right top, it means this is just this slide is just to provide extra info. No need to learn it about. So according to CAS, Chemical Abstract Service, there are about 66 millions of compounds. 66 millions. And out of 66 million compounds, 9 million compounds are of carbon compounds. And one more thing, around 12,000 compounds have been prepared every day. Means a day is spent and 12,000 more compounds. Okay? So out of 66 million compounds, 9 million compounds are of carbon. Means carbon alone forms 9 million compounds, 90 lakhs compounds. That is why carbon has been given a specialty to be studied separately under the heading of organic chemistry. Okay, so what is the definition of organic chemistry? It's study of carbon and its compounds. Then scientists saw that beside carbon, in all the organic compounds, hydrogen is also there. So they changed the definition a little bit. A study of hydrocarbons and their derivatives. What do you mean by the word derivatives? Obtained from, like we are the derivatives of our parents. Similarly, if we have a compound and you transform it into another one, then that compound is called the derivative of the first one. So all hydrocarbons, as you will see afterwards, all hydrocarbons are included in organic chemistry, and all those compounds which are obtained, which are the derivatives of hydrocarbons, they are also included under the umbrella of organic chemistry. So what is the complete definition of organic chemistry? Study of hydrocarbons and their derivatives. For example, all kinds of carbohydrates, proteins, fats, lipid, butter, margarine, petroleum, fuel, all of the, most of the petroleum, diesel, etc. All of these are the organic compounds. Glucose, sugar. Okay, so it's a very, very long list. It contains most of the common compounds that we know. Remember one thing, there are certain compounds, though they contain carbon, even then they are not included in organic chemistry. What are those compounds? Carbon dioxide, carbon monoxide, all carbonates, all bicarbonates, all cyanides. These are the compounds which are not included in organic chemistry. Why? Because in such compounds, carbon is not linked with hydrogen, or you can say the properties of such compounds are different from those 9 million compounds which are included in organic chemistry. That is why they are not supposed to be the part of organic chemistry or organic compounds, but in other. So, right? These are the different compounds. As you can see, polyethylene, polyester, PVC pipes, chocolates, or fiberglass, etc., etc., etc. All of these are the organic compounds. So organic compounds are all around us. Most of the medicines that we use are the products of organic compounds. Cosmetics, as I told you earlier, food, as I told you earlier. Some drugs are made of small organic molecules like aspirin. Well, I told you what is the full name, what is the chemical name of aspirin? Acetyl salicylic acid, right? Insulin. These are all our organic compounds. I'm just trying to show the importance of carbon compounds. That why carbon is given a very special, a specialty to be studied separately. These carbohydrates, all of these. Okay, so organic chemistry covers medicinal chemistry, pharmacology. Pharmacology, you know, is study of drug in action. Suppose a drug is prepared in a lab, then the scientist, the chemist, will see that what is, how can you use this drug, this medicine for the benefit of on humankind, on human beings. So this is polymer chemistry, or you know, polystyrene, thermopole. This is polymer chemistry. This remember the cross sign at the right top. So this slide is only for your info. No need to learn it. What will you learn? What will you learn only? What is organic chemistry? The study of hydrocarbons and their derivatives. This you are going to learn. This you are going to memorize. Okay, let's proceed the next. Inorganic chemistry. What is inorganic chemistry? If a study of carbon and hydrocarbon in this compound is called organic chemistry, then all the other rest of the compounds, 66 millions minus 9, how many? 57, correct. 57 million. Study of 57 million compound is called inorganic chemistry. Now it includes the compounds of all the other elements, like water. It contains hydrogen and oxygen. Water is studied in inorganic chemistry, like hydrogen chloride or hydrochloric acid. It is studied in inorganic chemistry. So all of these are inorganic compounds. That is why the definition is there. The study of all the compound except organic compound, and those compounds which were kicked from the organic chemistry. Which ones? Carbon dioxide, carbon monoxide, cyanides, carbonates, bicarbonates, or hydrogen carbonates. These all are also the part of inorganic chemistry. All right. So this is inorganic chemistry, a study of all the compounds but organic compounds. It includes salt, water, oxygen, all kinds of paints, this and that, all. Okay, now let's